having, if it appears somewhere, yes. It's the potential of being self-sufficient, of managing its own IT infrastructure, in being able to, let's say, handle yourself without the use of consultants. For this reason, we have aggregated a set of projects that are called OpenNebula, ExtremeFS, and so on, that came from the European research with quite a strong open source, let's say, community behind. And we are turned it then into an instant cloud. It's a USB key. It contains its own hypervisor, its own operating system, everything that is necessary for you to have your own cloud in 60 seconds. I've just booted my notebook with the key inserted. It's, and basically what you get is a web browser with everything already configured for you. If you take this key and you take the notebook of one of my colleagues down there, you will get another new node, another configuration that's perfectly adapted for that infrastructure. The nice thing of this system is that it requires basically no maintenance. It finds the other nodes on the network on its own. It is capable of adapting itself on the different conditions. And you already, you have your own, well, let's start a Windows machine. Why not? You have your virtualization platform, your cloud platform, really in 60 seconds. And the nice thing is that if your server fails, you remove the key and everything follows you to the next server. You don't have to reconfigure anything. It does include a distributed file system that shares your file across your network so that even if one or more of your server fails, you don't lose anything. And it is capable of doing it not only locally, but across a wide area network. So it's possible to create a geographic distributed disaster recovery configuration simply by creating a visibility for the P1 with the other. And that's it. It's fairly simple. The principle is that this is something that you can show to basically your accountant, and it can create your cloud in really 60 seconds. The aspects that are hidden behind, we have implemented features for high availability. We have created a version that is specific for data centers, that's capable of packing together all the virtual machines in the most efficient way, and they can shut down the servers that are not necessary anymore, so you can save power. We have created a version that is used in industrial control that support hard real-time properties, and it is used in the largest ceramic producers in Italy to control their plants. And if one of their servers fails, it really is transparent. It moves its VM to another site. They experienced no downtime since they started working on this. We have customers among civil protection agencies. They are basically the most life-critical infrastructure that you can get. But you got customers as well in the small accountants that discover that if their server fails, basically they are unable to work anymore. The second aspect that is interesting is the optimizer. When you have more than one node, or when you have a little bit of diagnostics about the machine that you are running, it starts collecting data and it starts to propose modification on its own. This is exactly. This is the optimizer that is probing what the machine is doing. It's recognized this is a desktop, that I'm using a desktop VM, and the proposed improvement is 3%, because we are not proposing very large changes in configuration, because this can disrupt the guest virtual machine. The interesting thing is that the improvement is incremental. After 1 or 2 days, your virtual machine will go 20-30% faster, especially if they are single-load virtual machine, for example, a PostgreSQL database. One of our customers had a very large PostgreSQL database, several terabytes of it. They moved from VMware to CloudWeavers, and after 2 days, they got 45% faster. And the interesting thing is that they have not invested a single euro in optimizing it. The reality is that if we move let's say, expertise from VMware or Citrix or Microsoft to somewhere else, we are not helping small companies. They will not be able to afford it anyway. What we are trying to do is creating something that can be used by really anyone and can be used as a basis, for example, for distributing software as a virtual appliance, or that it can be used as the basis for a growing infrastructure inside of data centers, inside of medium-sized companies, and so on. The other interesting aspects of this project is the fact that basically everything that is done through a web browser. Even the graphical interface is HTML5, so it can be used on an iPad if you want. And the other aspect is that really it allows you to partition your IT and delegate administration. One of the most important uses that we have found is that in lots of small companies, some of the internal IT is handled by external companies. For example, the ERP usually is managed by an external company. You have something like a VPN or something like a hole in the firewall to allow for updates and so on. With this, you can give to your ERP provider login and password, and you can make it sure that it can enter and manages only its own machine. It can reboot, it can update it. And you have all the features that make, let's say, virtualization interesting. Snapshot, the capability of returning back in time, and so on. It goes from one single machine, like this one, it's a single node, to our largest installation is 25 physical servers for a total of 60 cores and several terabytes of RAM. So it scales quite well. We believe it's a good project, and that's one of the reasons why we are giving back all the pieces and all the patches to the individual projects like OpenNebula, ExtremeFS, and so on, that allowed us to create this. Thank you very much.
Thanks a lot. Merci beaucoup, Carlo. C'est vrai que d'être le premier, c'est pas forcément